Welcome to this class. This class will be studying about kinematics of a particle moving in a straight line or a plane. So let's list the objectives of the chapter. So by the end of this chapter, the learner should be able to, so the first objective, define a projectile. Number two, derive equations related to projectile motions. Number three, solve problems involving the motion of projectiles. Number four, solve problems involving motion in a straight line. When acceleration varies with time. Number five, use calculus and vectors to solve problems involving motion in 2 dimensions. So those are the objectives of this chapter. And this first introductory session, let's give some definitions of terms related to what we're going to study throughout this chapter. So introduction, we start by defining what we mean by a projectile. So by a projectile, we mean a particle that moves in a vertical plane. So this is a particle moving in a vertical plane. So particle moving in a vertical plane is termed as a projectile. So we can use projectile motion to model the flight of a golf ball. So you can use motion, projectile motion to model the flight of a golf ball. And then let's see the assumptions taken when you are describing projectile motion. So assumptions. One, we assume that air resistance can be ignored. That simply means that to describe projectile motion, the assumption is that there's no air resistance. Number two, objects can be modeled as particles. Objects can be modeled as particles. Number three, the force due to gravity is uniform and acts vertically downwards. And then assumption number four, objects only move in a vertical plane. So this means there is no side-to-side movement. So when you're modeling projectiles, the only force which is of interest is force of gravity. All other forces do not govern the projectile motion. So we can say usually the only force acting on a projectile is gravity, which is assumed as being constant. So that one should always be clear. the force which governs projectile motion is force of gravity. So another point we can say, when other forces act on a projectile, they can vary with time. For instance, a rocket traveling in space fuel is burned and the mass of the rocket decreases, with time. So when the fuel burns, the mass reduces as time increases. And then in this case, the acceleration of the rocket is not constant, but increases with time. So that's what you have. And then just to insist, know that a projectile moves in 2 dimensions under the action of only one force, the force of gravity. Which is constant and acts vertically downwards So that point must always be remembered whenever you are modeling projectile motion, that there is only one force which governs this motion, and that the force of gravity that is assumed to be constant and acts vertically downwards. This means that the acceleration of the projectile is g meters per square second vertically downwards and there is no horizontal acceleration. These points will help us to derive equations related to projectile motion. There is no horizontal acceleration. So that's what we have. And then, so remember the force of gravity is assumed to be G, constant G meters per square seconds, and acts vertically downwards. Because we know acceleration is a vector quantity, so direction matters. So when the object is, or the projectile is moving upwards, then the acceleration will be taken to be minus G. When it is moving downwards, then that would just take us G. So those should be very clear because they'll help us to describe the motion of projectile in terms of some equations. So another point to remember, when a particle is projected, with speed u, at an angle alpha with the horizontal, it will move along a symmetric curve. So this is what we mean. So we can describe this. So we can draw the graph here. If this is horizontal, and then this is the initial speed of the object, which makes an angle alpha with the horizontal, then this is how the motion will look like. So it will be symmetric. To the horizontal. So this is what it means. So like this, divides into equal parts. So the initial speed u is called the speed of projection of the particle. And the angle alpha is called the angle of projection or angle of elevation of the particle. So that's what you have. Now, the initial velocity of the projectile can be resolved in two components. Into two components. So we have horizontal, and then we have vertical. Now, this is what we have. So remember we said if the angle between the initial velocity u and the horizontal is alpha, so this is the motion. So the angle so this u. Now then this angle here is alpha. So if we draw a right angle triangle with this initial velocity u, then we can use Oshachota to help us get both the vertical and the horizontal components of the velocity. Now, Oshachota means that to define sine of the angle is simply opposite of hypotenuse, and then to define cosine of the angle is simply adjacent of hypotenuse, and then to define tan of the angle is simply given by opposite of adjacent. So that's what the acronym of Oshachota means to help us to define some trigonometric ratios. Now, this distance here, horizontal distance here, with respect to this angle is adjacent, and this, let me call this one ux, and let me call this vertical one uy. So remember, this distance and this one is still the same. So this also uy, this will be the same as ux. So if you take cosine of alpha, will be given by this one, cos is adjacent, which is ux over hypotenuse, which is u. And then sine of alpha will be given by this height, which is uy, u sub y, over the size of the hypotenuse, which is u. And then from this one, you can make u sub x the subject. So we have u sub x will be given by u cos alpha. And for this other one, u sub y be given by u sine alpha. So those are the components of velocity in both the horizontal and the vertical directions. So we say the horizontal component of the initial velocity is u sub x given by u cos alpha, where alpha is the angle of projection, and the vertical component of the initial velocity is u sub y equals to u sine alpha. So those are the components. So in the next session, we'll now be describing the equations which govern projectile motion. So thank you for listening to the introduction. So let's meet in the next session.